Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, I'm going to give you Wednesday's update. Basically, I wanted to make a 3D printer like this, but better and by my own design. So my designs have progressed significantly. So I went from having nothing to some idea. This is a rough blocking, basically how my 3D printer will look. And this is the basically build plate volume, and you can say I have the build plate, then I have the silicon heater. It is like around 300 400 watt silicon heater. Then there is insulation, then we have the frame, basically support frame. That support frame bolts onto basically linear rail blocks, and those blocks ride on these rails. And this is the C channel, and do not mind this because again this will be cut. I have not chopped it off yet, so of course it will, in real world this will not be happening. So this was just a rough idea, like what the hell I want to do, like how my final design will look. Now because I'm using Cartesian style printer rather than Core XY, the consequence of that will be it's a bit longer. It will not look as square. Basically if you look from top, it's like, yeah, better, because this part has to travel complete distance of itself. So 300 millimeter in this direction, 300 millimeter in this direction. So basically print head can easily reach all these areas. Now that's the aim of it. Now this is a rough blocking. Of course I will fine tune it because I already made a mistake in this puppy, is because I'm planning to have dual extruder. This is not wide enough. Basically this area, it's not wide enough. Motors have to go way too far. Allow me to change to this. Yeah, as you can see, like motor almost have to come out this area, but this part is the basically pillar. This pillar will have the linear rails and all that jazz, which will, oh, I think I have accidentally closed the folder. That's unfortunate. But references. Yeah, you can see like what I'm trying to create is something similar to this. Basically, I'm gonna have a stepper motor, linear bearing, and threaded rod. Now be mindful, this is a CNC department's NEMA 23. I'm dealing with NEMA 17 now. This is that's why this area is not accessible to me, and my core design element is everything has to be enclosed. I cannot have things poking out how this design has there. As you can see, like the build plate ends here, the frame ends here, but somehow this part extends on. There is no gonna be extending on, so it has to be inside that, and that will allow me to bolt this frame much more rigidly. I have this printer in real life, Ender 3, so I know for a fact that it's not very rigid. So this puppy is built in a such a way so it can be super rigid. Basically, as you can see, I can mount this puppy from here, mount it from here, and here, and here. Basically I can mount it from all the side, and even on top I'm limited, like I can't put anything in this direction simply because there will be motor and linear bearings, but I can put something in this direction, something from here. Basically I can reinforce the hell out of this puppy to make sure this is absolutely rigid. So it's not just a looking cool department, it also makes it everything rigid. And if all the joints are properly aligned, you're talking about some seriously tough hardware basically. And not to mention I want to enclose all this puppy in metal, even a sheet metal. The reason for that is we are talking about serious amount of energy being dumped into it, especially with this silicon thing. This can go it's around 300 watts of heating power, so it's a lot of things. And other things, so it can catch on fire. So you want to make sure the enclosure contains the fire in case if it ever catches on. Most likely will never happen. And modern basically computers which will be on top, basically all the electronics will be outside of the build chamber. Here basically there will be a box kind of structure on top. I have not decided that yet. So in those box structure every electronics will be there. So basically two Z-axis motor will be coolest because they do not have to be inside the build chamber, so they will not be hot. But this motor, basically Z-axis motor, will suffer, not Z-axis, Y-axis will suffer, X-axis will suffer, and extruder motors, they will suffer. So that's the whole point. So I will just fine tune this design, have some joining blocks hopefully done today, and then my main goal will start designing a extruder. That's the main puppy. Now as you can see, I'm trying to aim for something like this, basically a dual extruder design. But you have to be mindful, I'm not going for board and tube. I hate board and tube idea, and not to mention they are not very good for flexible filaments, and they always have a bit of slop factor to it. I don't want sloppy design, so I'm gonna go for direct drive. And this is generally done for direct drive, but you can notice this is what we call a single system. Basically you have your stuff coming down here, and then there is a generally cooling block also attached here. They have opened it so you can see the mechanism, and this is the heater block. Now this will be the core of my design, but you can notice this is direct drive. Basically you have filament here and stepper motor is driving that. Consequence of that, stepper motor NEMA 17s, they are not that powerful. Even the big ones, they are not that powerful. And filament, they are notorious for if this puppy clogs up, basically nozzle clogs up, the energy required of this motor would be too damn high, and it will skip steps, which happens. You will like kit 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 kit, steps skipping will happen. And if spool tangles, which is a common issue with me, the spool always tangles, ends up getting tangled. So at that point it will not be able to pull through, so it will destroy your print. So is there a solution to that? Yes. If I can just scroll to that, now this is the solution. This is the most advanced system you can do for basically 3D printer design. This is what we call stepped geared dual drive. So like what the hell that means? First you can see there is a step down. So this is a stepper motor shaft, and this is a driven gear. So benefit of that would be let's say 2 to 1. Basically you're gonna reduce your RPM, but you're gonna improve your torque, which is more necessary for filament extrusion. Your filament is not like that's not happening on filament. You need more oomph. So this takes care of that oomph part, so you do not have to be like, okay, it's barely skipping steps. So that removes that problem. Another aspect you can notice, this has dual teeth. Why it's there? Well, if you go to, hold on, if I open the normal one, come on, come on, come on, come on, come on. Yeah, if I open the normal line, you can see there is teeth on one side. So filament is gripped on one side, but another side is completely smooth. What will happen if you are putting too much pressure on the filament? Consequence of that would be teeth will dig in, but because this side is smooth, they will strip it like you're gonna basically grind it away, and that does happen. Shaving and this will clog up. So this is good enough, like it does work, that's the reality of it, but it's not very rare. Basically you cannot close your eye and count on it. This will work 100% of the time. So people go with dual drive. So that way, because it's been driven from both sides, stripping probability is gone, and it has to be geared. It cannot be just like a free floating, because same thing will happen with the bearings. So this is the best system you're gonna have. Now Hemera basically is the most advanced system right now, and it does all of that in one very small compact block. So it's quite amazing. This Hemera system is quite amazing, but I do not like the design of it simply because the heat sink and heater is on one side. I cannot basically make these two like this. I have to make them like that. Consequence of that, if I do that, the basically nozzle, the actual 3D printing part, that's very far away. You want it to be as close to the frame as possible, so it has less oscillation. Basically, if you are making something that oscillates like this, it does not move too much, a little bit much, lot of oscillation. So that's the reality. You want it basically this puppy as close to basically frame as possible. Now again, if you have single print, Hemera is the best there is. But if I want dual, this design is not suited. It's not that it's worse, or it's not like it's unusable, but it's okay. And you can see Hemera, they have learned a lot. So they have even metal gear, which is necessary. If I want to ever print ABS, the chamber temperature will go hot enough that if this was printed in PLA, it will warp. Basically it will literally, there is a risk that it might strip apart. So again, I may this is the part that I have to figure out how I'm gonna get these sort of gear. These are very small, and I've not even seen any bearings that are that small. So it's gonna be a difficult problem. Like these needle bearings, I have no idea what they are called. So this is going to be a big tough challenge, but at least I want to figure out the designing phase. This project is much bigger than I anticipated, and I'm like happy and sad for it. Happy that I'm learning things, sad because I do not think I can finish it in in this week. So this will become a secondary part, and my main channel is stopped permanently because of this. So big thanks, small packages. So I hope you like this update and at least see some behind the scene. I'm trying to record every steps that I'm manufacturing. I'm saying building it. So at the end of it, I could have a complete time lapse. And because you're seeing day by day update, like how little progress I have made, it's not like tada, there is a 3D printer. Like it takes time to design it. And again, if any of you are like actual CAD engineer, they're like, bro, give me 5 minutes, I'm done. I know I'm an idiot. So that's why slow builds up to happen. Now this was an update. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'm truly sorry for the background noise. And okay, I'm gonna end it. The background noise is too damn high. Sorry about that.